the second half of the Module 4 review. So we're doing transformations. So remember, when you do something that's inside, you're talking about horizontal, and you do the opposite operation. If it's on the outside, you're doing it on the outside. This part, this is a vertical move. This is a horizontal. So it says, select all transformations that represent the graph. So horizontal, right here we have 2. But remember that that's like taking half of x. So we're doing a horizontal compression and then a vertical translation because it's moving up. The function blank is stretched horizontally and reflected across the x-axis. Okay, so we have a stretch horizontally, so that means that the number is in front of the x is going to be greater than, not 1. No, try that again. Stretched horizontally. So that means it's going to be between 0 and 1. Reflected across the x-axis, that means that it's going to be negative on the outside of the absolute value. So, okay, negative on the outside, that's not going to be this one. It's going to be one of these two. Now, stretch horizontally, that means the number inside has to be between 0 and 1. So that means that we have to pick C. The transformation that changes the slope or the steepness of a graph is called a dilation. The graph f of x equals x is known as the parent function. The absolute value function is an example of a piecewise function. Yes, because we have this way has a positive slope and this way with a negative slope. This is true. Describe the absolute value function. So remember, absolute value is normally this way. Whoopsie daisy. Okay, so we have a reflection over the x-axis, and we have a vertical translation of 3. So that's going to be g of x equals, and then the reflection over the x-axis, that's on the outside, and plus 3. Over here, again, this is where we start. Okay, so it still has a slope of 1. So that means that there's no dilation. Oops. It moved to the right 2. It moved down 1. So a horizontal translation of 2 and a vertical translation of -1. Okay, so g of x equals x minus 2, and then on the outside -1. Okay, so all this means is I'm going to move to the left 7. So I'm going to go to the left 7. I'm going to put my vertex point. Make sure I have a slope of 1. Make sure I have a slope of -1. And there we have it. This one, the only thing that's changing is I'm going to go down 3. So I still have a slope of 1. I don't think that was a slope of 1. All I've done is move my vertex. Got to get a slope of 1. There, I think that's a slope of 1. And a slope of -1. I think that looks good. Okay, so this means I'm going to go to the right 3 and I'm going to go down 10. So right 3, down 10 is here. I still have the same slope. That's pretty good. It's not perfect, but it, no, don't like it. Still don't like it. It's going down. It's like moving. It's like, you see it's how it's not staying. See, it's going down to that. That's what the problem is. It's wanting to hook to that. There we go. That looks better. Yeah, that looks better. There we go. Okay, so this one, now this one's a little bit different. So I'm not moving left or right. I am going down to -6. Now I have a slope of 3. So I'm up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Pretty good. There we go. Now this one, I can't just do that too. I have to actually make a T-chart for this one. So -1, 0, 1 normally would be 1, 0, 1. On this, the first thing I have to do is I have to subtract 3. So -4, -3, -4. Then with this, I have to multiply that by 3. Not 3, 2. Because it's the reciprocal of what's right here. So multiplying that by 2, I get -8, -6, -8. Then I can take my y value and subtract 2. So -1, -2, -1. So when I go to plot this, -8, -1. -8, -1. And then I go to -6, -2. And then I go to -8. Oh, silly girl. Tricks are for kids. This should be +4. This should be +8. No. I'm having a really tough time today. If I subtract 3, oh my gosh, if I subtract 3, that would be -2. That would be -4. Don't ask, I don't know. -4, -1. Okay. There we go. When it's a horizontal movement, we have to do things like that. So now we're going to flip it over, and it goes down to 4. So we do this, we flip it over, and it has a slope of 2 and -2. And there we have it. Okay, that didn't work. There we go.